everyone. Hello, everyone. I'm Ana-Maria. I'm a data product manager at Exol, and I've been managing projects for more than 4 years now in the role of a project manager and now as a product manager. And I'm here today to tell you a story, the story of how one of my first projects went. And as you might have guessed from the topic of this presentation, it was a data science project. So several years ago, I was starting my career as a project manager, as part of a tech company working on an innovative project. I was fortunate enough to be part of one of the best technology companies, working with a strong engineering and management team. ShittyPay, one of the best companies out there. You just have to trust me on this one. And the company had a clear goal. The company wanted to become a data-driven company. So there was I, assigned to coordinate all data and machine learning projects. Considering my experience in data and AI and also my passion for data machine learning. So our assignment was a hard one. The top management was asking us, the data team, to build a predictive model which will detect customer churn. They were asking us to do that on a low cost, and what they were looking for was us detecting which customers are likely to cancel their subscription to our service. Talking about customer churn, so this is the percentage of your customers that are terminating your subscription on a certain time period. So let's say that at ShittyPay we have 10 million subscribers per month, and there are 2 million that are canceling their subscription. So this gives you a churn rate of 20%. Customer churn is a common problem across many businesses in many sectors. Companies usually want to grow, they want to become more successful, more profitable. That's why you have to invest in acquiring new customers. And usually, attracting new customers is more costly than retaining the existing customers. So that's why you would want to predict customer churn. And so we started the work. We had everything that was needed. We had the data, we had the infrastructure, we had a team of experts, we had a very strong data team consisting of big data engineers, data analysts, machine learning engineers, and we also outsourced a data scientist to help us to build the model because our team members didn't have previous experience in building machine learning models. And we worked hard. We were sacrificing day and night sometimes weekends. And it was all worth it because we had a wonderful result. We obtained a well-performing machine learning model with 93% accuracy. This was a great achievement for the team. Just one problem. This project never made it to production. We didn't deliver it, and nobody was so excited as us within the data team. And soon I was starting asking myself, okay, what did we do wrong? Why is this happening to us? And when I started to find out what's the root cause, first thing I did for sure was Googling it. Okay, why is this happening? And you know what I found out is that most of the data science projects fail. There are researches done by Gartner, by VentureBeat, and the numbers are saying that more than 85% of the projects fail, of data science projects. You can see the numbers here, but I want to have your opinion a bit here. So why do you think a data science project will fail? Any ideas? Okay, results. No one wants to see the results. Okay, any other ideas? Money, okay, data. Okay, some good answers. So Google is also helping you here because if you're Googling it, the most common reasons is the data, the talent, so the lack of experienced data scientists, and the buy-in from the top management, the commitment. But in our case, we had it all. We had the data, we had a team of experts, we had the buy-in and the commitment from the top management. However, this project was ruined. So I want to tell you how it all went, how it all started, and how we reached that point. So it all started when the top management or the director of the company was asking us, the data team, to deliver this machine learning model because we have a large number of customers or users that are unsubscribing from our service, and therefore this is a problem for us. We want to retain existing customers. And as with any new project, we started with some questions like, what are the goals of this project? How to get familiar with data? What are the problems you're trying to solve? Which skills are required? How will you evaluate your model? And where to begin? Usually, one essentially key step is having a strong planning and process. And I will stop a bit here talking about planning and processes. And I want to mention that having this strong planning and process is important for any project, be it a data science or software engineering project. And data science and software engineering are somehow overlapping and complementary fields. They are both high-tech fields. They are both based on computer science and math. But if you dig deeper into discussion, you find out that they have their differences. So data science is more exploratory. You're always trying to find the insights from the data, while software engineering is more heavily code-oriented. Next, data science is much newer as a field, while software engineering was there for years and years now. And prior to this previous point, business teams usually have less of a clear idea what to expect from data science teams and from a data science project. And lastly, data science project management should be more open to changes. So given all these differences, managing a software engineering and a data science project is also different. So with a software engineering project, you go with a traditional approach, such as waterfall, or you go with an agile approach, with a Scrum framework, Kanban, extreme programming, or any others that are there. While in data science, everything is focused around data and modeling. And there are many frameworks out there because every data science team is different and every project is different. One of the most famous framework is CRISP-DM, the one you see here. So you start with business understanding, then proceed with data, data understanding, data preparation, modeling, and finally you deploy the model. This is one of the most popular framework out there for data science projects. And there are other frameworks. I decided to talk a bit about OCM, which stands for Obtain, Scrub, Explore, Model, and Interpret. And you can see that OCM is more like a linear flow, and you don't have that business part where you try to understand the problem and to deploy your final model. So within our team, we studied what's there on the market, and we decided on our own data science steps. We all agreed, okay, we're going to start with problem definition. We're going to then follow with data investigation and cleaning. We're going to build a minimal viable model, then do the deployment enhancements if needed, and the last step to be data science ops and ML ops, because that's what is said, to finish with ML ops, continue to maintain your model. It looks like a straightforward process, linear process, but actually it looks like that. Actually, you're going to start with one process, then follow with the next one. And having a couple of small iterative steps is better than having one compressive phase. So we started with problem definition. The problem was clear. We wanted to reduce the existing user's churn. And what we did as a team, and what I did as a project manager, was gathering the requirements from top management, from our directors. The next thing, I was talking with marketing director, business analysts, to collect opinions and feedback. And once we had all those feedback collected, we started with data investigation and cleaning. This is where you identify what data is needed, understand your data, and prepare the data for machine learning model. And fortunately for us, we had all the data available. The big data engineers extract the data. We had the data set, which contained data about the customers who left in the last 6 months, the data regarding what services each customer has signed up for, data about their account, how long they've been a customer, how often they use the service, what are the monthly charges, what are the total charges, and lastly, demographic info, such as gender, age range, and if they have partners. The next thing, our data team was preparing the data set for machine learning modeling. So they cleaned the data, performed descriptive statistics, identified the outliers, imputed missing values, and finally performed the feature engineering. And in the end, our data set had no missing values. The unnecessary features were dropped from the data set, and we're ready to start the modeling. And the first thing you do when you start modeling, you split your model into the training data set, validation data, and test data. The training data set is your labeled data set that helps your model to learn the hidden patterns from the data. Then you have a validation data set, which you're going to use to validate your model during the training. And lastly, the test data, where you test how well is your model performing. So, talking about customer churn, well, this is a classification problem, so it's a supervised machine learning problem, and usually that's how it works. You have your labeled data set, you split the data into the training and test data set, you train your model on the training data set, and evaluate the model on the test data. And finally, you have the performance, the accuracy of the model, and if you're satisfied, you can deploy it to production. And there are several metrics you can use to evaluate your model. Accuracy, precision, recall, confusion metric that I have here are just some of them. And here I have the results that we obtained within our team. We had a very good accuracy, 93%. We had a good precision of 97%. And the recall was 93%. And our confusion matrix was looking very good. Yes, you heard it right. For people who are not into data science, I said confusion matrix. So in our confusion matrix, we had the true positive, true negatives, false positive, and false negative values. And you can see that we have more than 3,000 true positive values, more than 1,000 true negative values, and the false positive were 119, and the false negatives were 271. This was a big achievement for the team, very good results. And there comes the glory moment for us, presenting the final results. So here we are, all of us sitting in a meeting room. There is the IT director, marketing director, a couple of business stakeholders I did not met before, but how cool was that? There are all of us sitting there, the data team, presenting the results, going through the slides. We present the performance of our model. And then, silence. I see some confused faces. And okay, then there is somebody breaking the silence, asking, hey guys, what's that precision? What's recall? And what's this confusion matrix showing us? Okay, that was not a question that we were expecting, but we're ready to answer this. So our team starts to explain what is a confusion matrix. So this is a combination of your actual values and predicted values. You have your true positive, false negative values, and other values, and it helps you to calculate the accuracy, precision, and recall. So true positive is the value that you predicted to be positive, and this is true. while true negative is the value that you predict in negative, and this is true. And you have your false positive value, which is the value predicted as positive, but is false. And you can see a very good explanation of how it works. Easy, no? And then we start drawing some formulas on the whiteboard. Data team starts explaining what's the accuracy. So accuracy will give you how accurate is this model predicting. Then you have your precision, which will tell you how many correctly predicted values turn out to be positive. Then you have recall, which is telling you how many actual positive values we predicted correctly. So, for example, precision is an important metric to look at when you're building recommendation systems, because wrong results can lead to customer churn, while recall will be an interesting metric to look at in medical cases where actual positive cases should not go undetected. And I'm sitting there. I'm so proud of my team. They explain it so well. They are so smart. This is great results. And then a customer success manager breaks the silence again and says, hey guys, these are some great numbers. Yeah, these numbers look good, this confusion matrix looks good, but sorry, I have no idea how I can use that. And I have to be honest, sorry, but I have to go back to business. I have no time for all this, what you're doing. And this was for sure not the reaction that we were expecting. What do you mean you have no time for this model? What do you mean nobody needs it? And then when trying to think, okay, what happened, how we reached that point, there are a couple of things that we understood. One of the first things that we understood right after that meeting is that we didn't engage all the stakeholders. Therefore, we didn't build trust, and we didn't get the constant feedback from the teams. Yes, we did have a very good communication with top management, with the director of the company. And for some reason, I was thinking that everyone was on board, that everyone knew what we are doing and why we are doing this, while in reality, I totally ignored the team, the one who's gonna work with this model. And I learned that stakeholders' continuous involvement is the key, as they're going to be the one to benefit from the project at the end. There is a second thing I realized, and that's that we didn't understand the real problem. Yes, we were solving a problem, but we did it because that's what our director was asking us, and because we wanted to become a data-driven company. And I learned that sometimes you have to challenge your top management. You have to challenge a director. I learned that sometimes you need to dive deeper to understand what's the root cause. And I gotta be honest, I wish I had more courage to ask more questions. Questions like, what does the business need? Who are all of our stakeholders, and what are their individual needs? What is the job that they're trying to get done? Do the stakeholders have clear expectations? What is the value of this project, and who exactly needs the data? And then there is one last thing I understood, and that was that we were overcomplicating ourselves. And here's one thing I want to tell you is that I feel like data scientists are very good at overcomplicating themselves. I don't know if you worked with them, but they're very sophisticated people who like to back up their statements up with data and complex calculations. And I learned that presenting data in a simple manner, with no buzzwords and without sophisticated terms, might be a better idea. Because while data scientists had their eyes on the data and the statistical formulas behind it, business teams look at other KPIs. They want to understand why the customers are leaving. What's the return of investment if we build this project? So we learned our mistake. We understood what we did wrong. And we decided, okay, let's do it again. Let's start again, because, yeah, data science is an iterative process. You can do that. But this time, following the right steps. So I started conducting interviews with business teams, with those people that I first time saw in that final meeting. And this really helped us to identify new features to be included in the data set. And then I started inviting all the business stakeholders to our frequent team meetings, and that helped us to understand what are their pain points, what are their expectations, how they see this product integrated into the business. And we took the time. The data team was experimenting with one model and then with another classification model. And sometimes I had the feeling that we are somehow losing focus because we were losing too much time on experimenting, and it felt like we are doing a research project. But it was fine. It was going well. We still had the feedback from the teams. We were communicating frequently. And guess what happened next? We deployed this model. We all agreed within the team that the best way to get this model out is to build an API, integrate that API with our internal system, and communicate to the system what is the likelihood of each user to churn. And we all agreed to score the customers on a weekly basis. And this really helped our customer success team. They were able to take proactive actions to contact and reach out to those high-risk users and to support them. And this really helped ShittyPay to increase their retention rate and satisfaction of the customers. What a wonderful use case. What a wonderful scenario. I just wish it was all true, because in the end, we were just fine. Yeah, in the end, we didn't deploy it because we never knew how we're gonna integrate this final project into the business. And I gotta be honest, sometimes we used to have small disagreements in the teams. There were different opinions. And this was painful to have those disagreements, but we didn't get to feel that pain for long, because soon enough, we didn't get to feel the smells around us. Guess what happened before this project could be integrated into the business and we could get the real value from the machine learning project? Well, the business changed their direction and the needs changed. The business was facing the pandemic. Therefore, the priorities changed, the needs changed, the goal of the company was a bit altered. And in the end, maybe it was a waste of resources of a couple of months. And I would say that it wasn't just a waste of resources. Also, the data science teams lost their commitment and motivation for future data science projects. And here am I, sitting there, asking myself, what would have happened if we didn't lose that much time experimenting with one model and then with another model? What would have happened if we didn't have all those disagreements, if we all just agreed on a low-level algorithm to integrate that model into the business and to showcase the value that the machine learning project can bring you? What would have happened if we didn't focus that much on the tools and technology that we use, but we all agreed that business needs is a priority? So in the end, what I can tell you and what I learned is that data science projects are no short-term projects. These are long-term projects involving a lot of steps, and sometimes the business needs can change in that period of time. And also, the business teams and top management can lose their passion, their motivation while waiting for the return of investment. And also, always put your business needs as a priority. Because in the end, it doesn't matter how good are your data scientists, it doesn't matter what technologies you use. What really matters is that business needs are satisfied. I'm still asking myself, what would have happened if we did things differently? But I'm letting you here to let your imagination run, imagine that wonderful scenario. Everything I can tell you for now is that that's how you ruin a data science project. Thank you. Thanks.
Thank you, Ana-Maria. Guys, if you have questions, I'm sure you have them. Just raise your hand. Don't be shy, please. Please.
Everyone still have to process the situation.
Yeah.
In case if you have to start the same process, but one more time, with your experience that you have for now, what would your first step on this way?
I would understand the needs and really understand what's expected. Because for me, one problem also was that I was new to the company. I was just starting out there. I didn't really have an idea of the business. I didn't have a good idea of what people are doing and why we're doing. I was excited that the top management was that, and I was excited having my first project. I was like, okay, we can do that. Wow, how cool is that? We're gonna be the first one company doing that. So yeah, just having more context of the business, how the business works, having more context of those stakeholders who are going to need the project and understand what exactly the job that people are trying to get done. So that would be it.
Thanks for your question. We can, if you have any more questions, we can ask them right now or answer them. Raise your hands. Don't be shy.
What happened to the data science team after all this mess?
All I can tell is that they learned a valuable lesson. That's for sure.
But they're still alive? No?
Yes, and they know how to deliver their project. I feel like they're still sophisticated people. They still talk in that statistical language, in data language, but they know that you have to collaborate more with your business stakeholders. That's for sure.
Thank you.